All right, so today we're gonna try to hit two birds with one stone. We're gonna learn about Gaussian functions. These are one of the most commonly encountered functions in physical chemistry, and in the process we'll learn how to we'll pick up some skills, new skills in Excel. Okay, so a good way to hit two birds with one stone. So we're gonna explore various aspects of the Gaussian function as we learn how to do things in Excel. Okay, so your objectives for this lesson would be to be by the end of this session, you should be able to describe a Gaussian function. You relate the plot of a Gaussian function, the shape, the peak, and the width to the parameters in the functional form. And then you're going to should be able to use Excel to plot a mathematical function. And one thing we're going to learn how to do is to evaluate integrals in Excel. Okay, we're going to learn two methods, the trapezoidal method and Simpsons Rule. And we're going to talk about how you can normalize a Gaussian function. If you have a Gaussian function, a Gaussian function is usually associated with a probability function. So if you have a Gaussian function, let's say f, and you integrate that from negative infinity, function of x, so integrate that from negative infinity to infinity, you set it equal to 1. Okay, so to normalize it, you just multiply it by a number. Okay, don't confuse this with the normalization that we do with wave functions, because in wave functions we integrate the square of the function, and because that's the probability. Okay, normalization in general just simply means scaling it so that it meets certain criteria. That's a more generic definition of normalization. So when you're normalizing a Gaussian function, usually it's something that's associated with probability density. So when you normalize a Gaussian function, its integral over all possible values is equal to 1. Okay? So what's a Gaussian function? It's one that you can write in this form right here. Y is equal to some number y max. Okay? So these are the parameters in your Gaussian function. Y max times e to the negative 4 ln of 2 x minus x center. So y is a function of x here. So x center is another parameter. And this x minus x center is squared. Okay? And you divide it by the square of another parameter called FWHM. So y max, x center, and FWHM in this expression are called parameters. Y here is a function of x. Okay, and so we're going to plot this in Excel. So we're going to set up an Excel spreadsheet, and we're going to put our y max, our parameters first. So we're going to put in cell A1, we just enter the text y max. So I'm just going to say y max equals, just follow along. Okay, and then in cell B1, you enter the value of y max. So for now, let's just set it to 1. Okay, and then in cell A2, we're gonna type just the text x center equals. And in cell B2, that's where we actually put the value of x center. And what do we have there? For now, let's set that to 0. Okay, there. In cell A3, we put the third parameter FWHM. And then in cell B3, next to it, we'll put the actual value of FWHM. So FWHM equals, that's just a text label. And over here, for now, we're going to set the value of FWHM to 1. Okay? So, you still with me? Now, we're going to tabulate in columns A and B values of x and y. Okay, so I'm going to put in cell A4, I'm just going to put the header for my x values, and in cell B4, the header for my y values. So what I'm going to do is I'm going to say x over here, oops, x. You have to hit delete so that it removes the extra characters that you don't want. And I want that centered, so over here in my ribbon, I can click center to center that. And then I'm going to put my y values here. I'm going to center that as well. Okay. Let me make that bold to emphasize it. All right, so those are my x and y values. And what I'm going to do is we're going to try to calculate the value of y from x equals -5 to +5 in intervals of 0.1. Okay, so what would be my first x value? -5. The next one would be -4.9. And then the next one is going to be -4.8. And that's going to take forever to type, right? Well, Excel is smart enough that if you highlight these first two numbers here, it knows that they differ by 0.1, right? And you see this thing down here? Oops. Let's see. You see this square block right here? When you hover over it, the plus sign appears. You can just drag that down, and Excel is smart enough to figure out that you want to continue that pattern the rest of the way. So if I drag this thing down, you can see it's telling me what number it's going to put. Okay, scroll it down, it tells me, and then you can go all the way to 5. So right there. That's what Excel did. 5, 4.9, 4.8, -4.7, and so on. Okay. And you'll notice if you look at the actual numbers, there's some slight round-off errors there, but don't worry about those. Okay. And that should really be 0. 2 times 7, 14. I can override that if you want. Okay. But let's just keep it like that. And if you want, you can set this to the format for this column to just say 1 decimal place. So you highlight it. The way you highlight it is you just click on one cell, and then you can drag your mouse. But Excel has a problem sometimes when you drag something down, it drags it all the way to the bottom, and it's hard to go back to where the end of the cell is. So an easy way is to just hold down the shift. When you're at the first cell, hold down the shift key, okay, and then just press the down arrow. You have better control for selecting things in Excel. Or you hit page down, that will just jump faster, okay? And so now you can just hit the up arrow to go back to the end of that cell. Okay? And then you just say format, right-click on it to format it, okay? So right-click, and then format your cell. And what do you want the format to be? You want it to be just a number with, let's say, 1 decimal place. And so you can see all your numbers are now formatted correctly. Even your 0 is now shown as 0, although it's actually 2 times 10 to the -2 times 10 to the -14. But like I said, that's a very, very small round-off error in the calculation. So that's your x. What do we do next? We need to enter the formula for the Gaussian function. What's the formula? Equals, so you say, let me blow this up a little bit. You say equals, so you type equals, and then you point to y max. Where's y max? Not this one, not A1, but B1. The value of y max is in B1, right? Times, how do you enter times? That's shift 8, asterisk. EXP, that's the function, the exponential function in Excel. Open parenthesis, minus 4 times, so hit shift 8 again, natural log, so ln, open parenthesis, and then the number 2, close parenthesis, So minus 4 times natural log of 2. What's next? Times, open parenthesis, x. Where's my x? This one right here, right? A5. That's my x. Minus, where's my x center? B2, right? 0.2, x center. Close parenthesis. And then square it. So shift 6, caret, will give it exponent. Shift 6, 2, caret 2. So that's 8y max times e to the negative 4 ln 2 x minus x center squared divided by, so slash, and then FWHM. What's the value of FWHM? A3, B3, not A3. B3 is where the value is. And then you have to square that, right? Oops. So B3, shift 6, 2, caret 2, close parenthesis. And that should be the number you get. Okay? Now, you obviously don't want to enter that formula for each and every one of those cells, so you can try copying it, right? So let's see what happens if I copy it. Right-click, copy, and then the next cell, I right-click, paste. Oops. Excel is complaining. Why is there a problem? Well, let's examine that formula. This one says B2. Well, that B2 is not Y max. It's X center. Okay? What happened here? I went from B1 for Y max, but in this next one, it's B2. When you refer to cells, when writing a formula in Excel, when you're referring to a cell, okay, and you copy that formula, Excel uses what is known as relative addressing. So when you said B1 over here, what Excel interprets that to mean is that take the value of, this cell right now is B5, right? What you're telling Excel here is take the value of the cell that is 4 cells above this one. So B1. So when you copy that, well, you're now in cell B6, so it's taking the value of the cell that's 4 cells above it, which is B2. It makes the adjustment. That's not what you want, right? But look at this one too. It says, what's your x right here? X is A5, right? This is your x. Your x is A5, which is this one. But what happens when it copied it? It's now A6 right here, which is negative 4.9. You want that, okay? So you want Excel to change that from A5 to A6, but you did not want Excel to change B1 to B2, okay? So by default, Excel uses relative addressing, so it's doing it right as far as adjusting the x, but you don't want it to adjust B2. So if you don't want Excel to do that, what you do, go back here to the original. You tell Excel, take the value in cell B1. I want the actual B1, not the B1 that's relative to where we are right now. So you put a $ in front of the B and the 1. Okay, I want it in column B, row number 1. Now, if you put just a $ on the B, that's going to be a problem because it will not adjust the B, but it will adjust the 1 when you copy. So you can do $B $1, or you can B $1. So putting a $ in front of the letter or the number just tells Excel that if I were to copy this, I don't want that thing that comes after the $ to change. So if I don't want B to change and I don't want 1 to change, I'm going to put $ before the B and a $ before the 1. Okay? What else don't I want to change? I don't want to change B2 because that's my X center. So this one, I have to put a $ before the B and a $ before the 2. What else don't I want to change? B3, FWHM. So I put a $ before the B and a $1 before the 2. Okay? Now, A5, I want that to change. So when I copy that, I want that to become A6. So I'll leave that A5 alone. So now I copy the enter. I've got that already edited. It's the same number. Okay? All I'm doing when I'm putting dollar signs is I'm telling Excel, when I copy this formula, don't change the number or the letter after the dollar. So now I can copy this. So I copy this and I paste it over here, and you can see Excel's not complaining anymore. And now you can just copy it down to the rest of your cell. You can just drag it like this, okay? Or if you want, you can copy that formula, and then you can highlight the rest of the column. Hold down the Shift key, press the down arrow or the page down to get there fast, and then right-click, paste. And, oops, what did I just do? Yeah, it's right there. Okay, so those are my numbers. So make sure you have the same numbers I have. You all caught up, or you need to pause for a while? You all caught up? All right, so that's your X and Y. Let's see what that plot looks like. How do you generate a graph in Excel? Most of the graphs you're going to be doing would be an XY plot or a scatter plot. So what you need to do is insert scatter plot. Okay? And generally when you do a scatter plot, you do not want to connect the dots. You just want to see points, right? Individual points, okay? Now the problem there is that's in general. That's what you've been taught, right? But if you're plotting a function, it's a smooth curve, right? If you want to show a smooth curve, you calculate it at very closely spaced intervals. In these cases, it's often useful to just not show the points, but just show a line that goes through the points. So when you're just plotting a function, it's not experimental data you're dealing with. The best thing to do is just when you're doing a scatter plot, do one where everything's just connected with smooth lines. Okay, and let me make this a little smaller. You don't have to. You can add that in later. Now sometimes Excel tries to be smart and figures out what it is you want to plot, and will give you a plot, and chances are you might have to change it anyway, because my experience with Excel is not always as smart as it should be. Okay, so if you do get a blank one or a blank chart or one that already has one, you can always fix it. So when you're on the chart, you'll see up here on Chart Tools, under Design, you can actually select the data that you want to plot. So when you select the data, if you have stuff that's already plotted, you can just click on those and then hit this Remove button right here. But I don't have anything, so I can just add my data. So I click on the Add button here, and right here I can give it a name. Okay, I don't have to. I can specify where my X values are by clicking on this one right here, this button right here, and then highlighting the X values, and then I can specify where my Y values are by clicking here. So let me specify my X values. So click here, and then I'm just going to highlight. It's best if you want to use the mouse for dragging stuff, start from the bottom going to the top rather than from the top going to the bottom, because when you go from top to bottom, there's a tendency to overshoot the last data point, and you'll go all the way to row number 65,000. So it's better to start from the bottom and then just drag upwards, and then you hit row 0, and then you just back up a little bit to the beginning of your data set. So this is from column from cell A5 to cell A105. Okay? So that's my X values, and then my Y values. I point to this one, and then highlight my Y values. I want to go from B105. So scroll up and go back up to the 5th row, from B5 to B105. Okay? And there's my chart right there. So what does a Gaussian function look like? It's a bell-shaped curve. Okay? Now, in activity 2, so we just did the scatter plot, okay? And then in activity 2, you're going to explore how changes in the value of y max and x center will affect the plot. Okay, let me just show you that. The nice thing about setting things up like this in Excel is now you can do some explorations. So for example, what if I made my y max 0.5? What happens? Look at the maximum value is 0.5. What if I make it 10? Oops. Oh, 0, nothing. 10. So, and then so I want you to explore. There's some explorations that I would like for you to do, so you can what's the word? You can correlate the values of these parameters, y max, x center, and FWHM, to the features of the graph. Okay, what aspect of the function, one aspect of the graph is affected by x center? What is it that's affected by FWHM? What is it that's affected by y max? Okay, so you're not going to do that today. You'll do that next time. So I'm just showing you. So activity 2, you're going to do it on your own. We're not going to do it together. Okay, so we're just going to move on to activity 2 and 3. Okay, so activities 2 and 3 are some explorations for you to familiarize yourself with the parameters of the Gaussian function and what they mean. We're going to move on to activity 4 now, which is, so that's activity 4, numerical integration. Okay, so if you have a definite integral, y as a function of x integrated from x with respect to x from x1 to x2, okay, that integral is just the area under the curve if you were to plot y versus x. Okay, now when I write this expression right here, that doesn't mean y times x. That's y as a function of x. Okay, so if you plot y versus x, let's say the plot looks like this curve right here. Okay, the integral, so that entire shaded area from x1 to x2, that's just the integral of y dx from x1 to x2. That's what a definite integral is. Okay, in fact, what happens if y is constant? If y is constant, if you go from x1 to x2, what's that area under the curve? It's just going to be y, which is constant, times integral of y dx is just going to be equal to what? Y times x, right? From x1 to x2, that's just y times x2 minus x1, right? So x2 minus x1 is just this width, and the height is just y. Width times height is the area of your rectangle. So imagine this as small rectangles then, okay? Break it up into small rectangles, and you can get the area under the curve as an approximation. But what we're going to do is we can get a better approximation by, instead of rectangles, we're going to use trapezoids. Okay, so the area under this curve, okay, we're going to approximate it using the trapezoidal rule with this, the area of this trapezoid right here. So our error would be this part right here, right? This is slight error. But if you make those intervals smaller and smaller and smaller, you can see that that error becomes smaller and smaller and smaller as well. Okay, so that's what we're going to do. So let's take a look at this trapezoid right here. Okay. What would be the area of that trapezoid? That's just the area of the square, which is, what's the area of the square? That's x2 minus x1 is the width. What's the height? y1, right? So the area of the square, x2 minus x1 times y1, plus, what's the area of the triangle? 1/2 base times height. What's the base? x2 minus x1. And what's the height? What's the height of your triangle? y2 minus y1. Oops. The height of the triangle is y2 minus y1. Okay, so that's the area of the trapezoid. Okay. The area of the square plus the area of the rectangle. Can we simplify this? I can factor out x2 minus x1, right? Common factor. This one and this one. So what do I have? x2 minus x1 times y1 plus half of y2 minus half of y1, right? But what is y1 minus half of y1? That's half of y1. Therefore, I can simplify this now. I could say the area is x2 minus x1, that's the width, right? What's half of y2, half of y1 plus half of y2? That's half of y1 plus y2, right? What's half of y1 and y2? That's your average height, right? So the average of the two y's. y1 plus y2 divided by 2. Think of it this way. If you imagine this halfway mark right here, this triangle right here, move that triangle, flip that over here, and that's the area of the trapezoid. Okay, so that's your formula for the trapezoid. Okay, so let's calculate the area of our Gaussian function, okay, in our Excel document. So I'm going to put the word A-trap in cell C4. C4. For the area of the trapezoid. So this first trapezoid right here, these first 2 points, oops, these first 2 points, this is going to be my x1, x2, this is y1, y2, right? So I'm going to put the area for that trapezoid over here. And then the next trapezoid, this one right here, this pair, I'll put the area over here. Okay? So let's do that. What's the area of the first trapezoid? Equals, let me make that bigger. Oops. So it's going to be equals, what was it? The width, right? x2 minus x1, correct? Times half of y2 plus y1, the average of the two y's, right? So plus y1 plus y2, y1 plus y2 plus b5 plus b6 divided by 2, or you can multiply by 0.5 if you want. That's the area of that trapezoid. Let me fix this up. I'll set this back to 1, okay? So reset your y max to 1, x center to 0, and add the duration to 1. So this should be the number you get. Okay, it's A6 minus A5, that's your delta x, times the average of B5 and B6. All right, so now, can we just copy that? When I copy it, do I want my A5 and A6 to change? Yes, because for this next one, I want it to be A7 minus A6. Do I want B5 and B6 to change when I copy? Yes, because now I want it to be the average of B6 and B7. So that I can copy. So I can just copy that down to the rest of my column. And I'm going to stop there. Why did I stop at 4 before the last data point? Because that's going to be your last trapezoid, right? This one doesn't have a point after it. So if I copy that to here, that's going to be a problem. Okay? There is no, look, there's no data point after that. So when you do your trapezoidal method for your integration, you'll have to stop at the second to the last point. So these are the areas of the trapezoid, right? So what's the integral from -5 to +5? If you're going to add up all of those numbers, what would those be? What would those correspond to? Those would be the integral from x equals -5 to +5, right? What was it? Y max times e to the -4 ln of 2 x minus x center squared over FWHM squared dx, right? So this is your Gaussian function. If you add those all up, you're adding up all those little trapezoids, you get the total area under the curve. So what would that area be? Just add them all up. Where does the handout say to put the area? Put it, so you should not have an entry for the last point. And then in cell D1, let's put the total area, the trapezoid, the text, and then cell E1 is where we're going to put it. All right, so D1 and E1. All right, so I'm going to say total area of the trapezoid equals, how do I get the sum of cells in Excel? You can say equals sum, open parenthesis, and then highlight the cells that you want to add up. So start from the bottom. It's easier to scroll up. Okay, so highlight, scroll back up, and then back up to cell C5. So you need to add up all the entries in cell C5 to C104. Those would be the areas of your trapezoid, close parenthesis, and the area of your trapezoid, and the area of the Gaussian function from x equals -5 to +5 would be 1.06447 based on this method. Okay? So that's activity 4. Now, activity 5, we're going to do Simpsons Rule. No, this is still activity 4. The second method you can use is called Simpsons Rule. Okay. In Simpsons Rule, the way you determine the area under the curve is, first of all, you need to have at least 5 data points to do Simpsons Rule, okay? And we have way more than that. And you have to have an odd number of points. And all of those x values for all those points must be equally spaced. So there's a limitation on when you can use Simpsons Rule, okay? So if you're going to use Simpsons Rule to do an integration, the data points must be equally spaced, x values, okay? So we're going to call h the difference between neighboring x values, neighboring points. So h is really your delta x, okay? The area under the curve, according to Simpsons Rule, is h over 3 times 4y1 plus 2y2 plus 4y3 plus 2y4 and so on. So see the pattern? It says 4, 2, 4, 2, 4, 2, and so on. And the last one will be 4 times y sub n. Okay? So that's the formula. So we need then to have some kind of column that would allow us to calculate these numbers. Okay? So first of all, let's make a column that says 4, 2, 4, 2, 4, 2, 4, 2. Okay? And so how are we going to do that? You're going to say here, okay, let's call this Simp C. Those are Simpson coefficients. 4, 2, 4, 2, 4, 2. So this is going to be 4, 2, 4, 2, 4, 2. Okay, and again, you don't want to do that. Keep doing that. So what a good formula you can use is the if formula. Okay, so you can say here, if the cell above is 4, then put a 2. Otherwise, put a 4. You got that? So if, open parenthesis, D4 equals 4, that means if the cell above is 4, then this must be a 2. Otherwise, this must be a 4. Okay? Or you can, alternatively, you can say if the cell above, what did I just do? Okay, let me do it again. If the cell above is 4, then put a 2, otherwise put a 4. Alternatively, you can say if the cell above is a 2, put a 4, otherwise put a 2. Same thing, okay? I mean, if the cell above is a 2, it's a 4, okay? Then put a 2, it's a 2, otherwise put a 4. So now if I copy that, what happens? Look what happened here. It says if the cell above is a 4, put a 2, otherwise put a 4. Since it's a 4 above, this one's a 2. So now I can just copy that cell, that formula to the rest of my column. And look, I've got 4, 2, 4, 2, 4, 2, 4, and so on. Okay? So if the cell above is a 4, put a 2, otherwise put a 4. So now, what do I do? My formula says 4 times y1 plus 2 times y2 plus 4 times y3. So I multiply the coefficient with the value of y, right? So over here, I'm going to say Simpson coefficient times y. So this is going to be equal to the Simpson coefficient, which is d5, times the value of y, which is b5. So this is 4y1. Or is it, And then I can just copy that because I want my d5 to change to d6 when I get to the next entry, and I want my b5 to become b6 when I get to the next entry. So I'm just going to copy that. To the rest of the column. And so that's my 4y1 plus 2y2 plus 4y3. Which one? This one? It's going to be the coefficient, which is 4, times the value of y. So this is 4 times y1. And this one is 2 times y2. And this next one is 4 times y3. And then this next one is 2 times y4, and so on. Okay? And so what's the total area according to Simpson's rule? What would it be? It's equal to the sum of these values, right? Sum of these. So I'm going to start from the bottom. Sum of these numbers, E5 to E105, but then I multiply that by what? H over 3. What is H? X2 minus X1. Just make sure that all of these are in fact equally spaced. So that's going to be A6 minus A5. That's your H. That's your delta X divided by 3. And you can see same answer, essentially. I'm sorry? Which one was your? This is just the sum of everything we tabulated in the CY column, in column E, times delta X, which is A6 minus A5, that's your sampling interval, divided by 3. Okay? So you can see that they give you more, same answer, essentially the same answer. All right. So in activity 5, you're going to explore the so-called normal distribution function. It's a Gaussian function for which the integral over all possible values of the independent variable is 1. So if you integrate p of z dz from z equals negative infinity to infinity, you're going to get 1. Okay? So p is like your y here, right? And z is like your x. So you can see this is essentially a this is going to be your y max, okay? And you have z squared, so that's z minus 0 squared. So your z center in this case, your x center is going to be 0, okay? So in this normal distribution function, you have two parameters, sigma, okay? You just have sigma, okay? Sigma determines what your FWHM is, and it also determines what your Y max is. If it's set this way, if it's set up this way, you'll find that the area under the curve is going to be equal to 1 from negative infinity to infinity. So you're going to explore that on your own next time, okay? And what else do we need to do? And then I'd like for you to explore calculate areas from negative sigma to positive sigma, from negative 2 sigma to positive 2 sigma, because that is something that we're going to be talking about later when we talk about statistics of measurements. Okay? And this is your post-lab report. I have the Word document on Moodle, so just download that, put your answers in the Word document, and then for your report, submit it back to Moodle with your answers in the Word document. Okay, so that's pretty much all the skills you need. So the rest of it you should be able to do on your own. Yes. If you want, you can just instead of sketching, you can just make a graph in Excel and paste. Okay. If you want, you can copy that thing on Excel from Excel to maybe Paint, and then you can add annotations to your. Like if this one right here, I were to copy this, I can copy this, and I can bring out Microsoft Paint. There's accessories. So, under accessories, where is Paint? Right there. And then you just paste it there. And then you can add annotations to it, like where's text? How do you add text right here? Okay. You can do arrows, like you can say, okay, that one. You can say that whatever. You can type whatever you want here. Whatever. So you can annotate it if you want to do it that way. Okay. Or if you want, you can freehand it and scan it, paste it to your Word document. That's another way you can go about doing it. All right. So that's going to be your activity for the next few days, next couple. So this will be due next week, Friday. So you have today, Wednesday, Friday. So today and next week, basically, to get the rest of today and next week to get this all done. Okay, so there's several explorations you have to do there. And,
like on Friday also, or?
Yeah, you'll have Friday. So this will be due next Friday at the end of lab time. So you should be able to do some of it on your own at home. You have Excel at home, right? So you don't need to be in the computer lab to actually do it. But this is that's it. Okay.